Yeah. Today's we're going to have a Unit 2 review. Now, Unit 2 is about problem solving. So, and uh, specifically to solve word problems. A lot of students have difficulty with the problem. Is a lot of times because they don't really understand what the problem is about, what kind of information they can gather from uh, the the words, the sentences, and also what is uh, asked for in this word problem. There is actually a good method, and mostly in physics, because physics you can solve a lot of word problems. It's called GASS, GUESS. So the G means given. So what kind of information is given in the problem statement? And U is what are the unknowns? U unknown, and sometimes is a plural. Then this E means you're going to set up equations, like what equations to use, or how do we set the equations. S is substitute. Basically, you substitute known values into the equation or equations. The last one, of course, is to solve the problem. So this actually can be used as a problem-solving strategy. Okay, so let's see how we can do that one. On this one, what's known? Well, first of all, what's given? The given that is atom speed is 65 miles per hour from A to B. And you can actually, at the intermediate step, you can use that to basically translate in this into what I'm doing here at the intermediate step, and then you set up the equations. So that's given, that's one. We also know that it's 55 miles per hour when they come from B to A. So you write those out. That will help you to understand it. And the entire trip is 12 hours. So that's what we know. But what's unknown? So that's unknown. Well, of course, the distance. We don't know the distance. Distance between city A and city B. We don't know that. And so we're going to talk about then trying to set the equations, and we'll see that. How do we set the equations on this one? Well, we can see that when we set the equations, we're trying to find some quantities that they are equal. So in this case, what's equal is the distance from A to B is the same distance as from B to A. So from A to B, we know the speed, and we don't know the distance. So if we don't know the distance, it's good to set up a variable because we are using algebra. Let's say it's called D for distance. And this is another unknown part is, so this is unknown here. This is 1 and 2. We also, even though we know total time, we don't know the time from A to B. So time from A to B. Now, even though we don't know the time from B to A, but if we know the time from A to B, then we can find time for B to A. So that's another time we don't know, but we can solve for that. Time from B to A. Okay. So therefore, the distance from A to B, then that is the speed times time. Speed is 65, so that's the equation we're going to use. Distance is speed times time. So the distance, 65 miles per hour. The time, we don't know, it's t. And then from B to A, same distance, and the speed now is 55, and the time, since the whole trip took out 12 hours, if from A to B is t, then from B to A will be 12 minus t. So therefore, now we can see, we can set the equation because this distance and that distance are the same. So we got 65 t equals to 55, 12 minus t. So that's the e part. We now set up the equation. If we can solve the equation, we'll find the time from A to B. Now, if we know the time from A to B, then we can solve for the distance because that's what's asking. Okay, so let's see how we do that. So now we set up the equation. And this actually is a linear equation, actually simple linear equation. We got, I'm going to rewrite it. So clean up a little bit. I'm going to rewrite it. And so we have 65t equal to 55, 12 minus t. And we have one variable, and this is called linear equation. So therefore, in order to solving it, we have to separate the known quantity and the unknown, which is t. So we use distribute property, we separate them out, and now we got 55 times 12. 55 times 12, that's 10, and so that's 110, then 5, so we got 0, 6, 6. So 660, then minus 55t. And then we have to combine the like terms. We got those two. So we add 55t and plus 55t. So on the left, we got 120t. And on the right, we got 660. So we divide by that on both sides. And what's our t? T will equal to 0, 0 cancel. And we can divide by 6 on top and bottom. So z 11 over 2, which is 5.5 hours. So therefore, in order to find our distance, we're just going to multiply that to the speed. So we go back to, we're going back to this equation. Okay, so the distance then is 65 times 11 over 2, and that we can use calculator to do that. Pretty simple calculation. So we got 65 times 11 divided by 2. So we got 357.5 miles. Okay, so that's how we solve this one. So let's have a recap, see where we got, how we got there. So first of all, what is G part? So we got GUESS. Okay, so the G part, we know that We know the speed, S1, let's call that S1 is equal to 65 miles per hour from A to B. And we know S2 is 55 miles from B to A. And then the total time, let's call that capital T, is 12 hours. So therefore, we don't know the distance. That's something we're trying to find, the distance between city A and B. So that's distance. So basically, when we are doing this, we are setting up our variables between A and B. So therefore, now we're going to set up a variable because we don't know. This is our unknown part. So we get to our unknown part now. This part is known. This is our given. That's our G. This part is our U. The T is time from A to B. So now we got into our equation part. This is E. So the equation part, we know that distance is speed times time. So distance will be 65 times T. And also the distance, this is from A to B. This is B to A. And will be 55, 12 minus T, because the total time is 12. So go in there is T, then come back has to be 12 minus T. And we know that they should equal, so 65T equals to 55, 12 minus T. Normally, when my student, when they were able to come to here, solving that actually become pretty straightforward. And just like we did early on, so we're going to distribute that. Then we got 65T equals to 660 minus 50T. Then we add 55T on both sides. Then we got 120T equals to 660. Then our T then is 660 over 120. So we got 11 over 2. And that's why we go back to this equation to find our distance. So because that's what they're asking, 65 times 11 over 2. And we got 357.5 miles. So that's how we got it. So you can see that we got find the given, find the unknown, then we set up equation, and we substitute the value. So those are the we substitute back in there. Because with the equation we're using is distance equal to speed times time. So we plug in what we know. In this case, we know the average speed. And then we set up the equation. We did substitution, then we just solving it. Okay, let's look at the second one. Bella's parent took turns driving to the favorite beach. Her dad drove half the distance and her mom drove the other half. Her dad's average speed is 70 miles per hour and her mom's average speed is 60 miles per hour. The whole trip took 10 hours. And when we're solving word problems, it's always helpful to sketch it, do some simple sketch. So now we say Bella is from her home and to the beach. So that's driving. And right in the middle, so her dad drove half the distance. So that's where her dad got to, which we know the speed is, so this is the given part, 70 miles per hour. And we also, this side is 60 miles per hour. And then we know the total distance. the total distance is 10 hours. Okay, so those are given. And those unknown, of course, we don't know the distance from here to here. Let's call that D. So D is the first half distance. Okay, and we don't know the time for the first half. Okay, and what we are trying to do is to find the total distance. So the total distance will be twice the D, right? Each one drive half. That's our D from here to here. Okay, so now we're going to set up the equation. And similar to what we did on earlier on, we know distance is speed times time. So our distance is equal to speed, 70, times time. And another one, second half distance is 60, and it's 10 minus t. Okay, and we know those because they are the two separate halves, so therefore they should equal. So we got 70t equal to 60, 10 minus t. Now you can see that this is very similar to our previous problem. So now we're going to distribute that. We got 600 minus 60t. Then we're going to add 60t on both sides. You can see that exactly the same process. So this 130t equals 600. Therefore, t is 600 over 130, and that gives us 60 over 30. So we keep that. Then we find the distance. Remember the distance d is 70 times t, which is 60 over 13. But the distance, total distance, then is twice of d. So that equals to 2 times 70 times 60 over 13. And we can just use our calculator and we round it to miles. So 2 times 70 times 60 and divide by 13. So we got 646 miles. Okay, so now we're going to looking at the second one. Well, you can see the third one. Second one, the first one is we're going from A to B and then B to A. And so we're just looking for the distance between A and B. So we don't have to multiply 2. Now on this problem, we find the first half, the distance, then but we have times 2 because they told us each drove half the distance. So that's the only difference between 2 and 1. Now we're looking at 3. 3, Cindy and her mom drove to a college for a college visit. She drove to the college and her mom drove back from college. Now this is basically the same thing as the first one, or same type of problem. So we go Cindy's home to college, and down here. She drove here and drove back. And drove there, her speed is 65 miles per hour, and come back is 60 miles per hour. And we also know the total time is 13 hours. Yeah, so it's very good to write it out, and you see that help you to set up. Same thing, the distance going from her home to the college, that's equal to the speed 65 times time, which we don't know. So that's where we set up as a variable. And come back from college to home is 60 miles per hour times 13 minus t. Okay, so now those two, this part and this part are equal. Assuming that we go in there, come back around the same route. So therefore we got 65t equals 60, 13 minus t, and that get distributed is 60 times 13. Sometimes I don't calculate until later, so I'll show you that. Okay, then we of course add 60t on both sides. So we got 125t. The other side is 60 times 13, and I divide by 125. So that's our t. Then we can divide by 5 on top and bottom. So we got 12 on the top, bottom. That gives us 25. So we just work on that. So basically we're simplifying it to make our calculating a little bit simpler. And then we divide by 25. So we got 6.24 hours. And we just need to find the distance. That's where we're going back to here. Now you can go back to here, but this one is relatively easier. So our distance then is 65 times 6.24. And what we got there, 65. Then we got 405.6 miles. Now, if you want to round it, we got 406 miles. Okay, now let's look at the last problem. In this type of problem, we're talking about the distance, speed and distance. Okay, so we see that it said Daniel drove from city A to city B at an average speed of 70 miles per hour, and his friend drove from city A to, not and, from city B to city A at average speed 60. So Daniel go here, and his friend Andy come here. So they are driving towards each other, and they started the journey at the same time. And the distance between city A and city B, so the total distance, and so the total distance is 260 miles. And it was said how many hours later did they meet? So they meet on somewhere on the route. So same thing, we know this is 70 miles per hour, and his friend 60 miles per hour. And in this case, we don't know the time when they meet. Okay, that's the asking, how many hours later did they meet? So that's where we set as a variable, as our t. So therefore, we can see the distance then becomes this part. The distance is 70 times t. And from here, his friend is 60 times t. Okay. So this, well, basically, we have one distance. That's for Daniel. That's 70 times t. And distance for Andy, in this case, well, they're driving the same amount of time. So We have the same t. Okay, and we know that add them together, d1 plus d2 is equal to total distance, 260. So that's how we set up our equation. So we have the given, we have the unknown, which is that. Then we set the equations. So we got then will be 70 plus 60 equals 260. That means 130t equals 260. We divide 130 on both sides. Then that cancels, so t is 2. That's 2 hours. That's what the answer to this question, because asking how many hours later did they meet. Okay, very good. Now we're looking at the age problem. And so here, again, we're going to translate that. Translate sentence into the math equations. First of all, said the sum of David's age and Tom's age 26. Now we don't know how old Tom is, so X will be Tom's age, David's age. And we don't know how old Tom is, this is Y, so Tom's age. And then we can translate, by defining X and Y, then we can translate that into algebraic equation. That is basically X plus Y is 26. And we also know that David's age is twice Tom's age minus 1. So that means David's age is X is twice Tom's age, 2Y minus 1, minus 1. And now we got this. This is we call system equations. And what they want is how old are they? How old are they? Basically, we're trying to figure out what X is and what Y is. Okay, this is a equation. It's called system equations. There's two ways to do it. One is called elimination, and another one is called substitution. And we're going to use substitution here because we have this one there already. So we just substitute X with Y. So that means we're going to substitute this X with 2Y minus 1. So the first equation is first, second. Our first equation, that becomes a new equation, which is 2Y minus 1 plus Y equals to 26. And on this side, then combining like term is 3Y minus 1 equal to 26. Add 1, add 1. So 3Y equals to 27. Then we divide by 3. Then Y is 9 years old. And then X now, that's 2 times Y minus 1. So 2 times 9 minus 1. That gives us 2 times 9, 18 minus 1, 17. So that's how we got that. Dave is 17 and Tom is 9. Well, we can check. 17 plus 9 is indeed 26, and 17 is indeed 2 times 9 minus 1. So we know we got that right. Okay. Okay, let's look at the second one. Second one said Sam is 5 years older than Tim. The sum of their age is 26. How old are they? Well, let's see. Same thing, we're going to set up variables because we don't know. So X is Sam's age, and Y is Tim's age. And then we're going to translate that into algebraic equation. So Sam, X is 5 years older than Tim, so it's Y plus 5. And we also know that the sum of the ages 29. So that means x plus y is 29. Okay, now we got this system equations. Same thing, we do substitution. We substitute this into this equation. So that means x now is replaced with y plus 5. Then plus y is 29. Then we got y plus y, 2y plus 5 is 29. Going minus 5 on both sides. Then 2y is 24. We divide by 2. Then y is 12. And so therefore our x then will be 12 plus 5. That gives us 17. So we know Sam's age now is 17. Tim's age is 12. Now we can see that 17 is 12 plus 5, and 17 plus 12 is 29. So we know we got them right. Okay, let's look at the next one. Alice is 3 years older than Lillian. 9 years ago, Alice's age was twice Lillian's. How old are they now? Well, let's see. Same thing, we got x, that would be Alice's age. And y is Lillian's. Okay, let's see. X, Alice is 3 years older, so x is y plus 3. And 9 years ago, then that means x minus 9. Then Alice, that's 9 years ago, it's Alice's age. That is twice Lillian's. Well, Lillian back then will be y minus 9. Because they all go back 9 years ago. So we got a second equation. And now we can change that one. We basically just work it out. X minus 9 is equal to 2y minus 18. So therefore x is 2y, and we add 9 on both sides, minus 9. So we got a new equation. So this is our first, our second, and third. Now the third one and the second one, they are equivalent. So it's different expression, but they have the same, exactly same information we have. So then we're going to do the substitution. We can, it doesn't matter which is substitute the x to this equation, or substitute x from this equation to 1. It really doesn't matter. So let's pick the, we just replace x with y plus 3. That means we got y plus 3 here, because x now is y plus 3, equals 2y minus 9. We all got, if we minus y on both sides, we got 3 equals to y minus 9, and we can write as y minus 9 equal to 3. We just add 9 on both sides. So y is 12. If that's the case, we know that x is y plus 3, which is 15. Okay, now we can see that Alice is 15 and Lillian is 12. So right now, Alice is 3 years older, but 9 years ago, Alice will be 6 and Lillian will be 3. So 6 is twice of 3, which means we got that right. Okay, now we're looking at the last one. Alan is 5 years older than Allison. 7 years ago, Alan's age was twice Allison's. How old are they now? So this is very similar on the third one. So we say x is Alan's age, and y is Allison's. So x is y plus 5, and then 7 years ago, so it's x minus 7 is twice, Alice's is twice of y minus 7. Then we can expand that. X minus 7 is equal to, this guy expanded, 2y minus 14. Add 7 on both sides. Then x is 2y minus 7. Okay. Now I'm going to, this time I'm going to replace this x with 2y minus 7. So we got 2y minus 7 is equal to y minus plus 5. So replace this with 2y minus 7. Then we got minus y on both sides. Got y minus 7 equals to 5. And add 7, 12. So y is 12. Now if y is 12, that's Allison's age, 12. And Alan is 5, so 17. Now, 7 years ago, it'll be 10. And Allison's 7 will be 5. So it is twice. 10 is twice than 5. Okay, all right. Now we're looking at the teamwork, this. So we said Alan took 30 minutes to clean up a classroom, and his classmate Adam will need 40 minutes. And they team up to clean the classroom. How many minutes do they need? So that's what we don't know. How many minutes will be X? And now, Alan takes 30 minutes to clean up a classroom. So per 1 minute, per minute, he can only do 1/30th. So it's a fraction of that. And Adam will be 1/40th. And together now, then times the time they need. You can use the X or use T, doesn't matter. So that should equal to 1. So what we got here is fraction. We add them, is 30 times 40, and cross multiply, 40 plus 30, and that is 70 over 30 times 40, and that gives us 7. We can cancel by 1 0, so it's that. And this is this part. So what we got here is 7 over 120 tx equals to 1. Now to solve this, we know we just multiply the reciprocal of this number. And we have to multiply on both sides. And that canceled, we got x. And 120 divided by 7, we got 17.14, so we just round it. So it's 17 minutes. Which makes sense because Alan will take 30 and Adam will take 40. Now, if Adam also can do 30 minutes, of course, together we're taking 15. But Adam took a bit longer, that's why this one is bigger than 15. Okay. All right. So all this problem very similar to that. And will be the same setup. So I'll let you do the rest. Okay. Bye. See you next time.